Atoms in the Periodic Table Introduction. This is the first lecture in our new unit. Atoms are the smallest part of an element that still shows property of that element. They have two parts or sections inside of them. There's the nucleus, or the center of the atom, and there's the electron cloud, which is a nebulous area around the nucleus. This varies in size depending on how many electrons that atom has. The nucleus and electron cloud are where subatomic particles exist. Subatomic particles are smaller parts as opposed to the atom. There are three pieces that are considered subatomic particles. The three particles or subatomic particles are protons, located in the nucleus, neutrons, also located in the nucleus, and electrons, located in the electron cloud. Protons are said to have a positive charge. This means they are attracted to negative charges and repel other positive charges. Protons are a large subatomic particle as compared to electrons. They're located in the nucleus of atoms, along with neutrons. Protons are how we identify different atoms. Protons do not move from their atom. Neutrons. These have no charge. They have a neutral charge. This means they're unaffected by how close they are to the protons, and they're unaffected by electric fields. Neutrons are located in the nucleus of an atom with the protons. Neutrons are the largest subatomic particle as compared to protons and electrons. And when combined with protons, they make up most of the mass of the atom. Neutron amounts can vary from atom to atom. Sometimes if an atom has too many or too few neutrons, we say they're unstable and they can break apart or decay. Electrons are negatively charged subparticles. This means they're attracted to positive charges and they repel other negative charges. These are how atoms interact with the world. Electrons repel each other when atoms contact, or they move and exchange to cause reactions. In a neutrally charged atom, the amount of electrons and protons is equal. The periodic table is an organizing tool used for all the atoms that we know. Each different type of atom is organized into rows and columns. They're represented by tiles. Here we have a representative tile of the oxygen atom. Up top we have the element name. Below the element name is the atomic number. Below the atomic number is the element symbol O. And below the element symbol is the atomic mass. Again, these are the four parts within each of the tiles in the periodic table. The element name. This is the name of the element. It is unique to each different element. The element symbol. This is an abbreviation of an abbreviation for each element. It's either one or two letters. If it's two letters, the second one is always lowercased. The atomic number. This is used to organize the elements. The atomic number is equal to the amounts of protons in the atom. Atomic mass. This is the average mass of all the atoms of that element. It is always a decimal, but it can be rounded to find the mass number. the mass number, is not displayed on the periodic table. However, it can be found by adding the number of neutrons and protons in the atom. It is the mass of an individual atom. If neutrons are missing, then we round the atomic mass to the nearest whole number to get the mass number. However, you only want to do this if you are not given the amount of neutrons in the atom. To find the atomic number, this is equal to the number of protons in the atom. The mass number, this is equal to the amount of neutrons plus the amount of protons. This is the first way to find it. Or, another way of finding the mass number is to round the atomic mass if you're missing the neutrons. Neutrons. These can be found taking the mass number and subtracting the amount of protons. Protons are always equal to the atomic number. Or, they're equal to the mass number and you subtract the number of neutrons from the mass number. Electrons. If there's no charge, then the number of electrons is equal to the number of protons in the atom. Take a moment and complete the table. Remember the following. If you're given a mass number, use it. If you have the neutrons, add the protons to find the mass number. If you have no neutrons, then round the atomic mass to find the mass number.